I have now recorded signals from many different sites. We will begin our offline analysis. At the top we can see pair number 9.1. That indicates that the last site that I recorded was number 9. Let's go to our first site by clicking on the left arrow, and you can see the different signals that we had recorded. This was the very first site. You may recall when I started these videos, the system automatically went into the analysis mode and the amplifier was off. And that's why this recording shows no meaningful potentials. I don't need to analyze this. I need to delete this pair. And I'm going to do so by clicking on the delete pair command. It gives me a warning that this will permanently delete the data and the live play. So I'm going to say yes. Now this is the first meaningful site that we recorded the data from. Now the jitter analysis on the Viking ADX system may be divided into 3 steps. The first step is to set up the so-called start and stop windows. I'm going to double click on the all trace data so that my explanation and manipulation of traces will be more obvious. On your system, this window will be quite large. You don't have to maximize it. Here are the traces that we recorded shown in a superimposed manner. And superimposed on it are 2 windows. The first one, which is currently shown in green color, is called the start window, and the second one is called the stop window. When the action potential crosses the start window, we start measuring time. When the potential crosses the second window, we stop measuring time. And the time difference then is the interpotential interval. This is further used for measuring jitter. The question that is often asked is, where should I place the window and how wide should it be? We like to place the start window on the sharpest portion of the potential, and this often occurs near the baseline over here. If you don't have a symmetric potential, you can put it halfway between the peaks. So somewhere over here is a good position for my first window. And the same principle applies for the second window. I can place it halfway between these 2 peaks. The second question is, how wide should be this window? It should be wide enough to accommodate or to allow all action potentials to cross. The system looks at the first crossing for measuring the interpotential interval. So if I were to expand this window, make it wider like this, it has absolutely no effect on calculations. It begins measuring time over here, and the subsequent crossings have absolutely no effect. So I can make it something like this. It should not be too short. If I make it something like this, notice that some of these potentials over here are not crossing the window, and my jitter analysis will not be accurate. So it should be wide enough to accept all the potentials that we have recorded. So this is how we position the window. So that's step number 1. Step number 2 is to look at the distribution of interpotentials, and that is done by looking at the result graphs. I will double click to maximize the window. The result graph shows the sweep number on the x-axis. So in this case, we are looking at 150 sweeps or 150 discharges of the motor unit. And on the y-axis, we have the interpotential interval. The system will automatically calculate the mean value of interpotential interval and its standard deviation. And the box shown over here represents 3 standard deviations above and 3 standard deviations below the mean. Now, if the data has Gaussian distribution, 3 standard deviation band contains 99% of data. Here we have 150 recordings, so probably 2 recordings may be outside this limit. And indeed, those are indicated by the blue symbols over here. Each symbol represents one interpotential interval. this interval is outside the 3 standard deviation band. And this trace is automatically rejected from analysis by the system because it doesn't fall within a Gaussian distribution. So this is the first method for taking out traces that may be of inferior quality or that may have noise and interference and so forth. The white values are included for analysis, and that's where the color combination comes into the display. White traces or white symbol are used for analysis. The blue traces are excluded from analysis. In this case, I have only 2 or 3 data points thrown out, which fits very nicely with a Gaussian or normal distribution. And I'm actually happy to see this kind of a pattern. I'm not concerned by 1 or 2 data points thrown out. So I'm not going to make any change to this. Double click. So that's the second step. And the third step is to look at the traces that are analyzed. And I'm going to do it in 2 stages. First of all, let's look at all traces. These are all the traces that we recorded. Here we have the white traces and the blue trace. Notice that the blue traces over here have a very long interpotential interval, and that's why they were excluded based on the statistical limit. Then we look at the active pair. These are the traces that were used for analysis, and here we find absolutely no noise interference or activity from other motor units that will corrupt our results. So I'm quite happy with my data analysis. So to summarize the process, we go to all traces, make sure our windows are positioned properly. Then we look at the result graph, we look at the distribution, and finally we look at the active pair, make sure there is no other interference. And once all of these are good quality, we can look at the summary results that are shown on the right. In this case, we can see the data from the active trace over here at the bottom. We cannot see all the details. So I'm going to click on the results knob over here, or the function key. This was my site number 2, pair number 1, 144 discharges were analyzed. The jitter was 14 microseconds. Mean interpotential interval was 663. The jitter was measured in 2 ways, MCD or MST. And in this case, the MCD was smaller than MST, and therefore that's the value of jitter we use. And further to the right, we see that there was no blocking and the firing rate was 8 Hz. So this is the summary statistics that is provided by the system. That completes analysis of the first action potential pair that we recorded.